Alright, let's solve some equations today, young people. In this equation here, my job is to find the value of x. On this side I've given some advice for the steps to take to solve equations. Always think isolate the variable, which means to get it to be the only thing on one side of the equal sign. Use inverse operations, where you see a positive number, subtract, where you see a negative number, add, where you see multiplication, divide, where you see division, multiply, etc., etc. And maintaining balance means doing the same thing to both sides of the equation. Okay, so when we have a fraction in an equation, and we'll see a couple of different kinds of things here today, I like to clear those fractions right away. And to do that, there's a little magic trick where you can just look at the least common multiple of the denominators and multiply by that number. So there's a 1 under there, a 5 under there, and a 1 under there. So the least common multiple would be 5. When I multiply everything in this equation by 5, I will get 25 plus 5 over 5, because this is 5 over 1 technically, so to multiply these fractions I'd get 5 times 1 in the numerator and 1 times 5 in the denominator, which would be 5 over 5 x, and that'll simplify and our fraction will be gone. Our equal sign stays in the exact same spot, and 5 times 5 of course is 25 again. We simplify that and we get 25 plus 1x, or just x, equals 25. I've got to isolate the variable, which means I just need to get rid of this 25. To zero that out and make it vanish, I would subtract using my inverse operation. Subtract 25 from this side. I have to maintain balance and subtract 25 from the other side, of course. And that is 0. I don't like to write that 0, but you could. The only thing left over here is x. My equal sign is right there, and 25 minus 25 is 0. And I just proved that A is the right choice. Now, with a simple equation like this, a lot of us are good enough with our math where we could just plug and chug, put 0 in there. 1/5 times 0 is 0. 5 plus 0 is 5, and you would know that that is right away. I'd like it if you did what I just did with all that work and then check to prove that it's correct. I could go through all of these, checking in them, plugging and chugging, as some of us say. Put a 2 in here, I'd have 2/5. 5 plus 2/5 is not going to equal 5. I could put a 5 in here and I'd multiply, I'd get 5 over 5, which is 1. 5 plus 1 is 6, so that wouldn't work. And 50 times 1 is 50, so 50 over 5 would be 10. 5 plus 10 is 15. That wouldn't work either. So again, if it is this simple of an equation, putting 0 in there and understanding that any number, even a fraction, multiplied by 0 is 0. 5 plus 0 equals 5. Pretty simple question, but they're going to get a lot tougher than that. Hasn't happened here yet, but like I said, if you're going to plug and chug, which is a strategy that's usable, but tougher when we get fractions, you could put 2 in here. 3 times 2 is 6, minus 4 is not going to be 10. Put a 6 in here. I'm going to 3 times 6 would be 18 minus 4. That's not going to be 10. But now doing these two in your head is a little bit trickier. So I would much prefer that we just solve the equation the way that we've been taught. Okay, so I've got a 2-step equation here. That's a 10. Sorry, I was writing a 2 for some reason. Okay, so 3n minus 4 equals 10. I need to use inverse operations and get this variable isolated. This is multiplication. This is subtraction. That subtraction is going to be easiest to reverse right away, so I'm going to add 4. Maintaining balance by adding 4 to both sides. What's left? 3n. And 10 plus 4 is 14. Now I see multiplication, 3 times n. The inverse operation is division, so I divide by 3. Divide by 3. 3 over 3 is 1. 1 times n is my n. That is isolated, equals 14 over 3. Now that equals either 4 2/3 or 3 2/3. Grab your calculator, do 14 divided by 3, and you'll notice right away that 3 goes into 14 4 times with 2 left over. 4 2/3 is the right answer. A little bit of work, not a big deal. Most students should be able to handle an equation like that by the middle of 8th grade at the latest, I would argue. Okay, now they start to make it look a little bit meaner. And again, we're going to use my strategy of multiplying. If I see a fraction in this equation, I want that gone, so I'm going to multiply the entire equation by the least common multiple of all the denominators. And I'm kind of lucky here because there's a 1, a 1, a 1, and a 1, and a 2, which makes it obvious that it's 2 is my least common multiple. If you want to put a 1 under it because fractions are easier that way for you, that's fine. 2 times 3 is 6. So we have 6 over 2x minus, and we have to multiply this 2 by everything in the entire equation. So 2 times negative 11 is negative 22, so minus 22. And 2 times x is 2x. And 2 times 4x, excuse me, I didn't mean to make that mark. 2 times 4x is 8x, so equals 8x. I hope I can leave myself enough room here. And 2 times negative 2 is minus 4. Okay. 6 over 2 simplifies to 3, so we're left with 3x minus 22 plus 2x equals 8x minus 4. We've successfully gotten rid of all the fractions. Now this is a pretty simple thing if we understand our like terms. 3x and 2x gives me 5x on this left side of the equation. So I've got 5x minus 22 equals 8x minus 4. And as I always say, I want to find, if I have the variable on both sides of the equal sign, I want to find the smaller one, which would be 5x, not 8x. So I'm going to subtract 5x. Maintaining balance by subtracting the exact same thing from both sides of the equation. That 5x zeroes out, is gone. 8x minus 5x is 3x. And my variable happens to be on the right side of the equal sign. That makes no difference. I still have to isolate it. So I'm going to add 4 first. And I have to be perfect with my integers here because some kids struggle with that a little bit, and we really need to work hard on that to be successful in algebra. But negative 22 plus 4 is negative 18. That'll equal 3x because this zeroed out. By using my inverse operations, I have multiplication, so now I divide. And negative 18 divided by 3 is negative 6. Clear the equation of fractions. It is a wonderful magic trick. Then all you have to do is what you should be getting real good at by now, solving equations. One more. This one's a little bit different. I want to distribute this first before clearing the fractions. And just hope you recognize that. Always, if you see distributive property in an equation, get that taken care of right away. Like I said before, there's always a 1 under these, so I like to put them there because fractions times fractions seemingly are easier for 7th and 8th graders than whole numbers times fractions. So I make them both fractions. I get 1 times 4 is 4, and 3 times 1 is 3. So I get 4/3 p. And negative times positive is negative, even when it's fractions. So 1 times 9 is 9. And 3 times 1 is 3. We don't have to do anything to the other side of the equation yet. We'll do that when we multiply the whole equation shortly. Just got that distribute taken care of. So I've got 8p plus 12 on that side. Now I've got fractions in here. I'm going to multiply everything, the entire equation, by 3. That'll give me 12 over 3p. And there's a little shortcut for that later, but I'm not going to share that today. 3 times 9 is 27, so 27 over 3 equals 3 times 8, which is 24, so 24p. And 3 times 12 is 36. Now, our magic trick, did it work? Will the fractions disappear? 12 divided by 3 is 4. That fraction's gone. 27 divided by 3 is 9. That fraction's gone. And I was successful in clearing fractions. Took a little bit more, but all you have to do is know distributive property and this magic trick, which I like to call it. Not really magic, it's just math. The most important subject, as everyone knows. Just kidding, language arts teachers and social studies teachers and all you good guys out there. So 4p, I'm subtracting the smaller one. I've got the variable on both sides again. I subtract the smaller one from both sides. See what I'm left with? This minus sign is still here, so that's negative 9 equals 20p plus 36. Now I've got to isolate the p. It's only on the right side of the equation again. That happens just about as often as the left side. It's the same thing. It makes no difference whatsoever, but it needs to be isolated, so this 36 needs to go. I'll subtract 36. Subtract 36. And even if you do struggle with your integers a little bit, there's no reason not to pull up a calculator, put negative 9 minus 36, and get the exact right number, which would be negative 45. Equals 20p. That's multiplication. We use inverse operations. We divide by 20. Divide by 20. And we'll have to, we know the answer is negative, so it's this one or this one. It's certainly not that or that, because negative divided by positive is negative. We've got to divide. Again, you could just use your calculator. 20 into 45, or into negative 45, I might say, is 2. That would be 40. And 5 is my remainder, so that's my numerator over 20. Okay, so now I have 2 and 5/20. 5 over 20 simplifies to 1/4, so my answer is negative 2 and 1/4. That's what that translates to. So we have to decide if that's this one or this one, and we'll finally have the right answer. Again, just grab your calculator. 15 divided by 4 is going to be 3 3/4. Use your calculator here, you'll get 2.25, which of course is the same as 2 and 1/4. So thank you very much for your attention. Make sure you get this strategy of multiplying an entire equation by the LCM of the denominators, and you can clear fractions and make your life a lot easier and make your math a lot easier. Thank you for your attention.